Okay. So yesterday we were discussing these equations, projectile motion. I have doubt whether you understood it or not. I'll explain once more. You can see, I'll explain once more this equation. Because I have doubt whether you understood or not. So let R0, vector R0 is the initial position at a time t equal to 0. And a body is moving with an acceleration, uniform acceleration. You have to think about a car. Initially, it is at Chandrapini, initial position and position vector from the origin. Vector R0. Then it reached to Vadanapulli. That is the final position. At a later time only it reaches. It takes some time to reach there. It is moving with an acceleration. Suppose uniformly it is accelerating the car. So with the uniform acceleration, body is moving. So at a time t equal to 0, position is r0. At a time t, later time t, position is vector r. So what is the displacement? Vector r minus vector r0. And if it is a uniformly accelerated motion, you know, at initial velocity is v0. That we know initially when it start velocity is v0. And finally as it is accelerated motion, its velocity increases, and finally at a time t velocity becomes v. Let us take it is v. So what all things I told now? Initial position r0. At that time velocity v0. Time 0 at a 0 time. Initial velocity 0 time. And the body is accelerated 60, 70, 80, 90, like that. Body is accelerated, uniformly accelerated. And then it at a later time t, after 5 minutes or 10 minutes, it will reach another position, vector r. At that time its velocity will not be v0, because it's an accelerated motion. Initially started with 0, velocity increases like that. Uniformly it is increasing. So here when it is at r, vector r, position vector r, time is t. At a time t only it reaches there. And velocity is v. Let the final velocity we are taking as v. So initial velocity v0, final velocity v. So what is the average velocity? Uniformly accelerated motion. So initial velocity plus final velocity by 2. That is the average velocity. And average velocity into time. What we get? Average velocity into time, displacement. We get displacement. So that is done here. So you can see. You can see here. See, r minus r0 is the displacement. Displacement is equal to initial velocity plus final velocity by 2. Always put this vector symbol as it is a two-dimensional motion. So we have to put the vector symbol into t, average velocity into time. And then what is done? V equal to v0 plus at, that we have studied earlier. So that is substituted here, v0 plus at. When you substitute, put vector symbol. Don't forget to put vector symbol, because this is a two-dimensional motion. We have to study all these vectors in component form, and also vector symbol is to be put on it. Then again this way v0 is written here again. So how many v0s are there? v0 plus again v0 is there. So 2v0 and by 2 is here. 2v0 by 2 and into t is there. So 2 and 2 get cancelled. We get e0 into t plus. Then what remains? At by 2 into t. At by 2 into t. Upper what we get? Half at square. Half at square. So v0 t plus half at square. That is the displacement. v0 t plus half at square. So this is the displacement. If displacement is asked, you can write this. If final position is asked, what will you write? Vector r equal to vector r0 plus v0 into t plus half at square. This R0 is given to the right side. So we get R0 plus V0 into T plus half A into T square. Okay, that, and we are splitting into component form. Next step, we are splitting into component form. Let us split that into component form. See, vector R is equal to vector R0. Yes. Vector R equal to vector R0 plus V0 into T plus half A into T square. And we are writing in component form. R, how will you split into component form? Xi cap plus Yj cap. R0, how will you split into component form? X0 I cap plus Y0 j cap. And into T is the, into T is the, R0, here is into T. V0 is expressed in component form. V0 x into I cap plus V0 y into j cap. Similarly, A is also written in component form. Ax I cap plus Ay j cap into T square. Then what is written? Its components are written. See, all x components are taken. From here it is x0, v0 x into t plus half ax into t square. That is green colored pen is underlined. All x components. Red color we have taken to understand the y component. Y component here, what is that? Yj cap. Here y0 j cap. Here v0 yj cap into t. Here half ay j cap into t square. So its components are taken. So y is equal to y0 plus v0 y into t plus half ay into t square. Motion in a plane can be treated as two separate simultaneous one-dimensional motion with constant acceleration along two perpendicular directions. So motion in a plane is actually, it is a two-dimensional motion and it can be treated as two separate simultaneous one-dimensional motion. One is along the y-axis, other is along the x-axis. So you have to consider it as separate. That is why we got two equations. Along the x direction, we can use this equation. Displacement along the x direction. X equal to x0 plus v0 x into t plus half ax into t square. Y equal to y0 plus v0 y into t plus half ay into t square. So when a body moves in a plane along the x direction, what is the displacement? What is the final position? What is time taken? For all, we use this equation. Along the y direction, what is its velocity? What is the time taken to reach that highest point? What is the acceleration? For all this, we take this equation. So it can be considered as two separate one-dimensional motions. Separate motion along the x-axis, along the y-axis. So motion in a plane can be treated as two separate simultaneous one dimension. Both are taking place at the same time. Two separate simultaneous one-dimensional motion with constant acceleration along two perpendicular directions. One is along the x-axis, other is along the y-axis. They are mutually perpendicular to each other. Then next, relative velocity in two dimensions. One dimension we have studied relative velocity. VAB equal to VA minus VB. VBA equal to VB minus VA. VAB equal to minus VBA. But the only difference here it is we put the vector side. There we put the vector side. That is the only difference here. Modulus when we take both are same. Modulus. Modulus of vector VAB equal to modulus of vector VBA. Modulus is same. But you have, that means modulus gives the magnitude. Direction will be opposite. One problem is there using this. What is the problem? Problem is not seen. Okay. I'll tell you later. So we were discussing about projectile motion yesterday, and I was not satisfied by your answering. I think it is idea is not clear. That may be the reason. So I'll explain it once more. Here, again, you listen because it is a very important question. Projectile derivations are there. You have to show path of the projectile is a parabola, and you have to derive the expression for time of flight. How much time it take when a body is thrown with a velocity, initial velocity. How much time it will fly in air? What is the highest point the body reaches? Highest maximum height attained by the projectile? What is the range? That range means this distance, horizontal range. That means horizontal range it takes when a body is thrown with a velocity v0. Okay, 36 students join. Okay. So when a body is thrown with a velocity, how much horizontal distance it cover? And what is the maximum height attained by the projectile? What time it will fly? How much time it will fly in air? All such things you have to derive expression for that. Okay. So when you study projectile motion, idea should be very clear to you. So here a body, for example, a stone. You can take a stone and you give some velocity. When you throw, we are giving some velocity to it. So this is a projection inclined at an angle. You can throw it upwards, you can throw it horizontally, but here the projection is inclined at an angle. Now, theta is the angle with which the body is thrown from the horizontal direction. From the horizontal direction, you can throw the body upwards, then angle will be 90, just upwards. So it will be angle will be 90. Then you can just throw like this horizontally. Then angle will be 0. But it is not thrown like this. It is thrown with an angle, just like when we throw a stone, like it move along this parabolic path. Body move along a parabolic path. Okay. The body is thrown with a velocity v0, and you see it is making an angle theta with the horizontal direction. Okay. V0 is the initial velocity and a body take a parabolic path. H is the highest height attained. Highest height, when body move upwards, what happened to its velocity? Velocity decreases and becomes 0. At the highest point, velocity becomes 0. And then velocity increases. When it comes downwards, velocity increases. Understand? That is happening. But here in projectile motion, we have to take both the component, x component and y component. X component and y component. So V0 initial velocity, it has got two components, x component and y component. How will you find these components? You just draw perpendiculars to the both the axes. Please children wait. Okay, Chandra. So here a body is thrown with a velocity v0. It has got two components, v0 cos theta and v0 sin theta. And v0 cos theta is the horizontal component and v0 sin theta is the vertical component. So when a body moves upward, horizontal component v0 cos theta remains same. That is what I was telling yesterday. v0 cos theta component will not change with the time. Why? Because there is no acceleration along the horizontal direction. No, nothing, no force is exerting on the body in this towards right or towards left. Only you can see the gravitational force which is acting vertically downward. Only that force is acting on it for the projectile motion. No other force is acting towards left or towards right or in the horizontal direction. So horizontal component of velocity remains same throughout the motion. Understand? Only the vertical component of velocity v0 sin theta will change with time. Why? Because body is accelerated downwards always. When body moves upwards, earth exerts a force on it downward direction. Understand? So what happened to its motion? Velocity decreases. Velocity decreases and becomes more. Then it begins to fall. When it begins to fall, what happened? Velocity acceleration is downwards. So velocity will increase like that. And just before it hits the ground, it will have maximum velocity. Understand? I think you understood now. When a body is thrown, after reaching a certain height, it is coming back to Earth. Land. Why? Because of Earth gravity. When it moves up, what happens to its velocity? Velocity decreases uniformly. Velocity decreases uniformly. And velocity becomes zero at the highest point. Then it increases. Understand? So that is happening here. So which component of velocity remain constant? Horizontal component of velocity. What is the horizontal component of velocity? V0 cos theta. Which component of velocity is changing with time? Vertical component of velocity. What is it? V0 sin theta. How it is changing? V0 sin theta minus gt when it goes upwards and V0 sin theta plus gt when it comes downwards. That is happening. That is what I explained yesterday. I think now it is clear. That is explained here. Okay. Then continuous object moves horizontal component of velocity v0 cos theta and continuously increasing vertical component of velocity due to gravity pull and finally strikes the point B, that is on the ground. Here AH is the maximum height and OB is the horizontal range. All those things I told you. Next, path of the projectile is a parabola. That you have to prove. That's a very important question. Show that path of the projectile is a parabola. You have to show that. For that, the same figure is taken. Same figure. But only one change is there. We have taken a point P. We have taken a point P here. At a time t, body is at P during its motion. And its coordinates are x coordinate, x is this, x coordinate, x, and along the y-axis it traveled OY distance, OY, along the y dotted lines are drawn from here. OY is the distance traveled along the y direction and OX is the distance traveled along the x direction. When body is at P, x coordinate is written here. That's how much distance it traveled along the horizontal direction, x. How much distance it traveled along the y direction, y. The OY distance. Okay. So x coordinate is written x, y. Coordinates of P are written as x, comma, y. Okay. Then here you can see x is the horizontal distance traveled by the object in time t and y is the vertical distance traveled by the object in time t. Then first we are considering motion along the horizontal direction OX. And I told you along the horizontal direction there is no acceleration. Horizontal velocity remains constant throughout the motion. So when you consider that motion, the position of the object at any time t along the horizontal direction is given by x equal to, that equation is taken, x equal to x0 plus v0 x into t plus half ax into t square. We have splitted that equation into two parts, x component and y component, and while studying horizontal motion, that x component is taken. Okay. Here x0 equal to 0, origin is x0, you can see origin, O is the origin, and the coordinates are 0, 0. Origin coordinates are 0, x coordinate 0, y coordinate 0. 0, 0 is the initial position. So x0 is substituted as 0. Then v0x means along the horizontal direction, what is the initial velocity? And horizontal component velocity is v0 cos theta. v0x means what? Horizontal component of initial velocity. Horizontal component of initial velocity. What is it? V0 cos theta. So we have to substitute that V0 cos theta into T. And then AX is 0 taken. Why AX is 0 taken? Because horizontal direction there is no acceleration. Only vertical direction there is acceleration due to gravity acting. Horizontally there is no acceleration. So AX is taken as 0. Putting these in the above equation, all these values are substituted in the above equation. What we get? You can substitute all the values. So x0, 0, v0 cos theta into t plus half into 0, acceleration is 0 into t square. So we get x equal to v0 cos theta into t. Therefore, t equal to x by v0 cos theta. We got the expression for time when the body move along the horizontal direction. T equal to x by v0 cos theta. Equation number 1. Next, motion along vertical direction is studied. Motion along vertical direction. Along the vertical direction, which equation we can take? Y equal to y0 plus v0 y into t plus half a y into t square. That equation is taken. What is y0? Origin 0. What is v0 y? Y component of initial velocity? v0 sin theta. What is acceleration? It is acceleration due to gravity, and we take it negative. When a body moves upwards or downwards, we usually take it as negative, minus g. So substituting in the above equation, we get the final position y equal to 0 plus v0 sin theta into t plus half into minus g into t square. So we get the equation y equal to v0 sin theta into t minus half gt square. That is the equation. Substituting 1 in 3, 1 means time, equation for time. This equation for time is substituted in this equation. So what we get, you see, y equal to v0 sin theta, x by v0 cos theta, t substituted, minus half into g into t squared and written here, x square by v0 square cos square theta. Then v0 cancel, we get x tan theta minus half g into g by v0 square cos square theta into x square. X square is written separate here. Here x is there, here x square is there. So this equation, you see, this is a familiar equation similar to that. Y equal to ax plus bx square, that equation. Have you heard of that? Y equal to ax plus bx square, which when you substitute, we get a parabola. Y equal to ax plus bx square. This is the equation of a parabola because this is a constant, a part, ax. This tan theta is constant, theta, that is the angle of projection, theta. Tan theta will be a constant value. And bracket, you know, this part is also a constant, g, acceleration due to gravity constant. Body is thrown with an initial velocity. We are not changing that. That's a constant. Theta is constant. So this part we have written in bracket, that is a constant part. So bx square, y equal to ax plus bx square, plus or minus, doesn't make any problem. But that form, it is in that form, y equal to ax plus bx square form. Understood? So this is the equation of parabola. And this is how we show that path of the projectile is a parabola. So what all things we have done to show that path of the projectile is a parabola? First we consider motion in x direction. and from that we got the expression for time. Then we consider equation along the y direction. Then that time we have substituted from the above equation. We substitute time. Time equal to t equal to x by v0 cos theta. Then we write in the form ax plus bx square form. Then we tell this is the equation of a parabola. Hence, path of the projectile is a parabola. This is the way to write. You children, please write and study. First, draw figure. What all things you have to do? Show that. This is the question. Show that path of the projectile is a parabola. That is the question. Then what all things will you do? First, you have to draw figure. Then you have to explain all the terms used in it. What is theta? What is V0? What is H? What is B? All things you have to explain. That is the explanation part, figure explanation part. That body is thrown with a velocity V0, and after reaching the highest point, it come back, and the path is a parabola, and like that you have to explain all things. Then you have to consider two motions, separate. This is projectile motion. Two types of motions are there: motion along horizontal direction, motion along vertical direction. And we have got two equations: x equal to x0 plus v0 x into t plus half ax into t square. Along the y direction, what is the formula? Y equal to y0 plus v0 y into t plus half ay into t square. So in the when you take the motion along x direction, there is no acceleration. When you take motion along the y direction, there is acceleration due to gravity. So separately you have to consider both the motions, and from the first motion along the x direction, we take the expression for time period, and that time period expression is substituted in the second equation, that is motion along y direction. Then we express this in this form: y equal to ax plus bx square. Then we can tell this is the path of the projectile, which is a parabolic path. Okay, this is the way. Then after writing this, you will get 2 marks. Like only 2 mark question. That is. Then next is a very very important derivation. Derive the we can derive the expression for maximum height. We can derive the expression for maximum height. Maximum height means a body reaches to the highest point h. What is maximum height? From the ground level to the maximum height. What is that height? That you have to find out. It is the maximum vertical height attained by the object above the point of projection during its flight. So for finding that, which equation you have to take maximum height displacement y, or y equal to y0 along the y direction, vertical height alle. അപ്പോൾ നമ്മൾ ഏത് ഇക്വേഷൻ എടുക്കണം? y എന്നുള്ള ഇക്വേഷൻ എടുക്കണം. ഇനി ഹൊറിസോണ്ടൽ റേഞ്ച് ആണെങ്കിലോ എക്സ് എന്നുള്ള ഇക്വേഷൻ ആണ് എടുക്കേണ്ടത്. ഇത് നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് മാക്സിമം ഹൈറ്റ് ആണ്. അപ്പോൾ വെർട്ടിക്കൽ ഹൈറ്റ് ആണ് വരുന്നത്. സോ വി ഹാവ് ടു കൺസിഡർ this equation: y equal to y0 plus v0 y into t plus half ay into t square. For maximum height, you take this equation, and horizontal range, we take the other equation: x equal to x0 plus v0 x into t plus half ax into t square. Okay, so maximum height we can see y equal to y0 plus v0 y into t plus half ay into t square. What is y0? Origin 0. What is v0y? V0y means what? Initial velocities y component v0y, that is v0 cos sin theta, v0 sin theta into t. So time of flight we have to calculate. Where is that expression? Here it is, time of flight. That after that only you can find that. Time of flight, first we have to find out. Time of flight means when a body is thrown with a velocity, how much time it remains in air? Just before it hits the ground, it will be there in air. That time, that is the time of flight. It is the total time for which the object is in flight, remains in air. While going from O to B, B means maximum horizontal distance covered. It is denoted by time. Time of flight is denoted with the letter capital T. But here there is two time when you consider time of flight, time of ascent is there and time of descent is there. I will show the figure. Yes, this figure is very important. See, time of flight means how much time it remains in air during its flight. So when it reaches from O to B, how much time it remains in air? That is time of flight. And in that, two times are there. What is time of ascent? How much time take to reach the highest point? And how much time it take to reach the lowest point? Time of ascent, O to H, that is ascent, and time of descent, H to B. That say they will take same time because the path is symmetric. The path is symmetrical, so it will take same time. This is the time taken to reach the highest point. Let us take that as small letter t. Time taken to reach the highest point, small letter t, and time taken to descend is also small letter t. So t plus t. 2 into small t, that is the total time of flight. 2 into small t is the total time of flight. Then how will you find the time taken to ascent? How will you find v equal to u plus at? That equation you can use. V equal to u plus at. V equal to u plus at, and it is a vertical distance. So you can use the formula Vy, y component you have to take. Vy equal to V0y plus Ay into At, Ay into T. So that equation we can take. So I will show that equation. This is the equation. See, Vy equal to V0y plus Ay into T. What is final? See, when it reaches the highest point, what is the final velocity Vy? That is 0. Final velocity Vy is 0. What is the initial velocity y component? V0 sin theta minus g, move upwards, minus g is taken. Minus g into small t is capital T by 2, time of flight by 2. Time of flight by 2. So V0 sin theta equal to gt by 2. Therefore, you can write capital T is equal to 2 V0 sin theta by g. This is the time of flight. Time of flight T equal to 2 V0 sin theta by g. So what is time of ascent? Half of that. Time of ascent. Time of descent also will be half of that. Total time is time of flight. So time of ascent, when you consider V0 sin theta by g only. V0 sin theta by g. So total time of flight capital T equal to time of ascent plus time of descent, that is equal to 2 into small t. Therefore, small t equal to capital T by 2. And we are finding this, see, using this equation to find the time of flight. So Vy, final velocity Vy, when it reaches the highest point, time of highest point velocity, final velocity is 0, and V0y is the initial component of velocity is initial component along the y direction. Initial velocity is y component, V0y, V0 sin theta minus g into capital T by 2. We are going to find the expression for capital T. That's why we take capital T by 2 here. Small t equal to, from this, small t equal to capital T by 2. That is substituted here. Then we get the expression for time of flight. Then time of ascent, half of that. What is half of this? By 2. If you put by 2 here, what happened to 2 get cancelled? And we get V0 sin theta by g. Okay. So time of flight we determine. Always remember. Do you remember what is time of flight? So what is time of ascent? Half of this. What is time of descent? Half of this. So you have to remember this expression to derive the next expression. All these expression you have to by heart. Maximum height is maximum height. Maximum height is found with this formula y equal to y0 plus v0 y into t plus half a y into t square. Y0 means origin. Origin it is 0. Y0, x0, x0, y0, 0, 0. So y0 is 0. What is v0y? Initial velocity is y component, v0 sine theta into t. Just now we have calculated time of ascent, v0 sine theta by g, plus half into minus g, acceleration along the vertical direction, minus g into t square. T already we know that is v0 sine theta by g whole square. Next, v0 into v0, v0 square, sine theta into sine theta, sine square theta by g, v0 square sine square theta by g, minus, here you see what is there, v0 square sine square theta by g square is there. That g square and this g cancel. So 1g will be there in the denominator. So what we get? v0 square sine square theta by 2g we get. Here it is v0 square sine square theta by g. So a common factor is there. v0 square sine square theta by g is common factor. Inside the bracket 1 minus, here we write 1 and here we write half. 1 minus half. And minus half is half. So v0 square sine square theta by g into half. So what is it? v0 square sine square theta by 2g. That is the expression. So this expression is very important. v0 square sine square theta by 2g. Next, one more derivation is there. Horizontal range. Horizontal range, that means the distance, horizontal distance it covers. Yes. It is the horizontal distance covered by the object between its point of projection and the point of hitting the ground. It is denoted by R, range. Which equation will you take? Batteries from okay, the horizontal distance covered by the object between its point of projection and the point of hitting the ground. I will show the figure, otherwise you will have doubt. Horizontal distance. This one. Figure is same. This is the horizontal distance, O to B, this distance. Maximum height we found. Horizontal distance means O to B, how much distance it can travel. See, if you know the velocity, initial velocity and the angle of projection, we can find out how much distance the body cover. 5 minutes more. That means OB. Which equation will you take? Only 5 minutes more. Which equation will you take? X equal to x0 plus v0 x into t plus half ax into t square. That equation we have to take. What is x0? x0 is 0. Origin. What is v0x? v0x is v0 cos theta. Horizontal component. v0x into t plus half ax into t square. What is ax here? What is acceleration along the horizontal direction? Is there any acceleration along the horizontal direction? No. So that half ax into t square will not be there. But time of flight, time v0 cos theta into t is there now. How much time will you take? Time of flight, you have to take time of flight, not time of ascent, not time of descent. What time you have to take? Time of flight, total time of flight you have to take to this to find this range. You b0 cos theta into time of flight, that will give the horizontal range. Let us see that expression. So this one, horizontal range, v0 cos theta into time of flight. v0 cos theta into time of flight we have already calculated, 2v0 sin theta by g. And you see we have written in another form. This is 2 is there. See, 2 sin theta cos theta, what is it? 2 sin theta cos theta, we have already studied, that is sin 2 theta. v0 into v0, v0 square. So v0 square sin 2 theta by g. v0 square sin 2 theta by g, that is the range. So we got the three expression now. Time of flight, horizontal range, and maximum height attained by the projectile. And also we have proved path of the projectile is a parabola. This is a sure question in exams. Parabola. Show that path of the projectile is a parabola. And also derive 5-mark question. Also derive the expression for time of flight, horizontal range, maximum height attained by the projectile. Either derivation or problem will ask very important portion. You have to write and study all the expression. Even though subjective exams are not there, you have to prepare well for that. Don't think that the derivation will not come. Don't think like that. You always prepare for that, because final January and all schools will reopen. It says like that. So exam will be there. All descriptive exam will be there. So prepare for that. Don't wait for the last minute. Write and study. Take a book for writing and studying, or and then all the equations you have to write in a that one paper. You write all the equation and fix it on your study place. Always study those equations like that, and you will remember all these formulas. Then maximum horizontal range, how will you find? In this equation, how it becomes maximum? Sin 2 theta. 2 theta is 90, then range will be maximum. When is 2 theta 90? Theta equal to 45 degree. Theta equal to 45 degree, 2 theta will be 90, and sine takes its maximum value 1, then range will be maximum. So RM, range maximum. Maximum range equal to V0 square by G. Maximum range equal to V0 square by G. So remember that. Range is this. For any angle you can find out the range, and for an angle of projection 45 degree, the range will be maximum, and equation is V0 square by G. Hence, to achieve maximum horizontal range, object should be projected at an angle of 45 degree with the horizontal direction. This concept has been used by athletes in long jump, javelin throw, cricket ball throw, etc. Understand?